According to the National Electrical Code, or NEC, a bathroom is defined as a room that contains a toilet, bathtub, shower, or any combination thereof. Based on the information given, an electric toilet is present, which meets the definition of a bathroom fixture. The code doesn't require a water supply or drainage system for a room to be classified as a bathroom. If there is an electric toilet in the room, regardless of water connections, the NEC considers it a bathroom. If an electrical panel is located inside this room, it might need to be relocated or protected against moisture and water damage to meet code requirements. The presence of the electrical panel in a bathroom requires action. This means one of two things. Firstly, the panel must be moved, or secondly, proper precautions must be implemented to protect it from moisture and water damage. Moving the panel involves physically relocating the entire electrical panel to a new location outside the defined bathroom space. This ensures it is no longer subject to the potentially hazardous conditions present in a bathroom environment where moisture and water exposure are more likely. Proper precautions might include using a panel that is specifically designed and rated for use in damp or wet locations. These panels are constructed with materials and seals that prevent moisture from entering the electrical components, reducing the risk of corrosion and electrical hazards. Another precaution would be to install a suitable enclosure around the existing panel that provides a barrier against moisture. This enclosure should be rated for the specific environmental conditions of the bathroom and should be properly sealed to prevent water from entering. It is important to consult the NEC and local electrical codes for specific requirements and to ensure that the chosen method complies with all applicable regulations. A licensed electrician should be involved in the relocation or protection process to ensure that the work is performed safely and correctly. They can assess the specific situation, determine the best course of action, and perform the necessary electrical work to meet code requirements. In addition to relocating the panel or taking protective measures, it is also important to ensure that all wiring and electrical components in the bathroom are properly grounded and protected by ground fault circuit interrupters, or GFCIs. GFCIs are designed to detect even small imbalances in electrical current and to quickly shut off the power, preventing electrical shocks. These safety measures are essential for protecting people from electrical hazards in bathrooms, where water and electricity can create a dangerous combination. Firstly, ground fault circuit interrupters, or GFCIs, are critical safety devices that protect against electrical shock. They work by monitoring the current flowing in a circuit. If a difference in current is detected between the outgoing and returning conductors, indicating a leakage of current to ground, the GFCI quickly trips, cutting off the power supply. This happens within milliseconds, preventing a potentially fatal electrical shock. GFCI protection is required in bathrooms, kitchens, and other areas where water is present. Secondly, proper grounding ensures that metallic parts of electrical equipment are connected to a common ground, providing a low resistance path for fault current to flow back to the source. This helps to quickly trip a circuit breaker or fuse in the event of a fault, preventing a dangerous buildup of voltage on the equipment. Grounding is an essential safety measure that protects against electrical shock and fire hazards. Thirdly, all wiring in a bathroom must be suitable for wet locations. This means using cables and conductors that are rated for exposure to moisture and water. These cables typically have a waterproof outer jacket and insulated conductors that resist corrosion. Using the correct type of wiring helps to prevent electrical shorts and ground faults, reducing the risk of electrical hazards. Fourthly, electrical boxes and fittings used in bathrooms must also be rated for wet locations. These boxes and fittings are designed to prevent water from entering the electrical connections, protecting them from corrosion and electrical shorts. Using the correct type of boxes and fittings helps to ensure the safety and reliability of the electrical system. Fifthly, any electrical outlets or switches installed in a bathroom must be GFCI protected. This means that they must be connected to a GFCI circuit breaker or GFCI outlet. GFCI protection is required for all outlets and switches within a certain distance of a water source, such as a sink or shower. Sixthly, lighting fixtures installed in a bathroom must be suitable for wet locations. This means using fixtures that are designed to withstand moisture and water. These fixtures typically have a sealed enclosure that prevents water from entering the electrical components. Seventhly, any electrical appliances used in a bathroom, such as hair dryers or curling irons, should be used with caution and should be unplugged when not in use. These appliances can be a shock hazard if they come into contact with water. Eighthly, it is important to keep electrical cords and wires away from water sources. Cords and wires should not be allowed to dangle near sinks or showers, and they should be inspected regularly for damage. Damaged cords and wires should be replaced immediately. Ninthly, if you are unsure about any aspect of electrical safety in a bathroom, it is best to consult with a qualified electrician. An electrician can assess the situation and provide advice on how to ensure the safety of the electrical system. Tenthly, the NEC, specifically Section 210.8, covers GFCI protection for personnel. This section requires GFCI protection for all 125-volt, 15 and 20 amp receptacles installed in bathrooms. The purpose of this requirement is to protect people from electrical shock hazards that can occur when using electrical appliances near water. The NEC defines a bathroom as an area including a sink and one or more of the following: a toilet, a tub, and a shower. The code also specifies that GFCI protection is required for receptacles located within 6 feet of the outside edge of a sink. This requirement applies to all types of receptacles, including standard outlets, USB charging ports, and other types of electrical connections. GFCI protection can be provided by a GFCI circuit breaker or a GFCI receptacle. A GFCI circuit breaker is installed in the electrical panel and protects the entire circuit. A GFCI receptacle is installed at the outlet location and protects only the outlet. When installing GFCI protection, it is important to follow the manufacturer's instructions and to test the GFCI regularly to ensure that it is working properly. GFCI should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. The NEC also requires arc fault circuit interrupter, or SI, protection for branch circuits that supply power to dwelling units. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. SIs work by monitoring the electrical current in a circuit. If an arc fault is detected, the SI quickly trips, cutting off the power supply. SI protection is required for most branch circuits that supply power to bedrooms, living rooms, and other areas of a dwelling unit. However, there are some exceptions to this requirement. For example, SI protection is not required for circuits that supply power to bathrooms, kitchens, or other areas where GFCI protection is already required. The NEC also provides requirements for the installation of electrical equipment in wet locations. A wet location is defined as an area that is subject to saturation with water or other liquids. Examples of wet locations include bathrooms, showers, and outdoor areas. Electrical equipment installed in wet locations must be listed for use in wet locations. This means that the equipment has been tested and approved for use in environments where it may be exposed to water. Wet location equipment is typically constructed with waterproof materials and sealed to prevent water from entering the electrical components. The NEC also specifies the minimum clearances that must be maintained around electrical equipment. These clearances are designed to provide safe access to the equipment for maintenance and repair. The NEC also provides requirements for the grounding and bonding of electrical systems. Grounding and bonding are essential safety measures that help to prevent electrical shock hazards. Grounding involves connecting the electrical system to the earth, providing a low resistance path for fault current to flow back to the source. Bonding involves connecting all metallic parts of the electrical system together, creating a common ground plane. These measures help to ensure that the electrical system is safe and reliable. In the given scenario, the determination of whether the room is a bathroom according to the NEC hinges on the presence of a toilet, regardless of its connection to water or drainage systems. The NEC definition focuses on the fixture itself, not its operational status. With an electrical panel present in a room now classified as a bathroom, several NEC articles become relevant. NEC Article 312.2 addresses the location of panel boards in damp or wet locations. It mandates that panel boards in such locations must be identified for use in those specific conditions and be protected against corrosion. This typically involves using an M4X rated enclosure that is waterproof and resistant to corrosion. NEC Article 408 provides general requirements for switchboards, switchgear, and panel boards. It covers aspects such as working clearances, guarding of live parts, and proper labeling. While not directly addressing bathrooms, it provides the overarching framework for safe panel board installation. NEC Article 240.24 addresses the location of overcurrent protection devices, such as circuit breakers in panel boards. It specifies that these devices must be readily accessible and not located in damp or wet locations, unless specifically approved for such environments. NEC Article 110.26 outlines the requirements for working space around electrical equipment operating at 600 volts, nominal or less. It specifies minimum clearances in front of the equipment, as well as width and height requirements. These clearances are essential for safe operation and maintenance of the equipment. Because the panel board is installed flush in the wall, it's necessary to ensure that proper working clearances are maintained even with a reduced space. NEC Article 314 covers outlet, device, pole, and junction boxes, conduit bodies, fittings, and handheld enclosures. It provides requirements for the installation and support of these components, as well as for the proper use of fittings and connectors. The type of box used for the panel board installation is crucial for ensuring its protection from moisture and corrosion. Because the electric toilet is supplied by a 240-volt, 20-amp circuit, this requires specific attention. NEC Article 210.6 outlines permissible voltage levels for branch circuits in dwelling units. It allows 240-volt circuits for supplying appliances and equipment, as long as certain conditions are met, such as proper overcurrent protection and grounding. NEC Article 250 provides requirements for grounding and bonding of electrical systems. It covers aspects such as grounding electrode systems, equipment grounding conductors, and bonding of metal enclosures. Proper grounding and bonding are essential for protecting against electrical shock hazards and for ensuring the safe operation of electrical equipment. Also, a 240-volt circuit requires a double pole breaker to supply the electric toilet. The fact that the sink only has cold water and drains outside is not relevant to the NEC definition of a bathroom or the requirements for electrical installations in bathrooms. The key factor is the presence of the electric toilet, which automatically classifies the room as a bathroom under the NEC.